Hello and welcome to this exciting video about Dagster. We'll use Dagster to orchestrate our DLT and DBT jobs into Snowflake. We're extracting, loading the data into Snowflake, and then we're transforming it. But what we have done before was to just manually do it by running the DLT script. And then afterwards, we were doing DBT run to run the DBT models. And then we got the data into Snowflake. But now we'll use another tool called Dagster that it can go automatically. And it orchestrates. You can make the jobs run based on other job that has been finished, etc. Then you will see this nice lineage in the Dagster UI later on. I will admit that this will be a little bit more complicated because I haven't explained all the concepts within Dagster from the ground up. I will try to make it understandable, but what I believe is that I will in the future make much more Dagster videos where I will explain and build on Dagster from scratch. You learn it from scratch, but in this video you should see it more as a demo type. I will try to go through the concepts, but I cannot go through all the concepts in details because there's a lot of concepts. It will make life much easier when you start to use Dagster. I hope that you can follow along. We'll go into some theory first before we go into the code, and in the code I will try to explain the theory while I'm coding as well. And also make sure that you have seen my previous videos before this project. It's about the job tech API. What we do is we extract and load the job tech data into Snowflake, and then we do the different data modeling with DBT. It's crucial that you have learned these concepts before, as I will pick the code from the previous video. I will link it in the description and put it into this project and have that as a starting point before I create the Dagster code. I will start in my repository. This is data orchestration with Dagster. Here we start with what is Dagster. It's a data orchestrator, which means that you will be able to schedule jobs. You will be able to make job run based on other jobs, etc. And what it is for is to automate the data pipeline. You don't need to run everything manually. Instead, it will run the pipeline based on a lot of different things. It could be like triggers, events, etc. It will produce data assets, and there's a term called software-defined assets, which define assets and their relationships. It's an execution plan inferred from these definitions. It's more declarative programming versus imperative programming. You declare what assets you want. There's a benefit for this asset-centric approach is that it's easy to manage the dependencies and you can monitor the execution. And you will see this in the Dagster UI later on. It's quite nice. Right now, maybe this sounds like gibberish for you and you maybe don't understand this, but it's totally fine. You should just know some basic concept that it's a data orchestrator. It's automating your data pipeline. That is what you need to know, and you have heard about assets. Then we'll go on to the core concepts here. In Dagster, there are a few things. There are assets, there are jobs, schedule, sensor, etc. And then in a Python script, there's something called definitions, where you collect all these components to build a specific workflow. Then they deployed for materialization. And in Dagster, there are a lot of different components. We won't go through all of these. However, we'll go into assets, job, schedule, and sensor, a few of them. And then the definitions is the Python script where we'll put this in. In this video, simplified it a little bit. I haven't used something called Dagster init. I haven't used their standard packaging. Instead, I tried to simplify it and put everything in one definitions.py, where we'll craft and put everything there, because this is maybe your first introduction to Dagster, and I want it to be somewhat more manageable and not care too much about how packaging works and how and all other files, how they work, etc. This is a little bit more simplified, I think. Later on, I will of course create more videos about Dagster, and then that will include their standard packaging and using and understanding all the different modules. But for this video, I think it's too much. That's why I've simplified it a little bit. That's the reason. Here, you can see there are these few things that we have. We have assets. It's a logical unit of data. For example, a database table, CSV file, etc. And an asset, it can have dependencies on other assets. It can depend on other assets. An asset can be used in a job, schedule, or sensor. And then what is a job? Job is the main form of execution. It contains a selection of assets. It can be scheduled by schedule or triggered by sensor. For example, something happens, then it triggers. A schedule is a way to automate job or materialization of assets at a specific interval. You can say, for example, once per day it will materialize, or once per week, or once per hour, you choose. After deployment, the automation is to be started in Dagster UI. Here, the sensor is a way to trigger job or materialization of assets when occur. Based on a certain event, then something will happen. Then it will trigger the materialization of the assets. And after deployment, the automation needs to be started in Dagster UI as well. You deploy it, and then you go into Dagster UI and you start it. Definitions, a top-level construct in a workflow. Only objects included in the definitions will be deployed and visible within Dagster UI. This is where we'll put our code in this simple example. We'll put it into the definitions. Okay, welcome to Visual Studio Code. Here is an empty Visual Studio Code. We'll start with a terminal here and do some installations. UV We started virtual environment, source.ven bin activate. UV pip install Dagster-DLT and Dagster-DBT. These, I think these are what we need right now. Okay. Now I've installed those, and let's create this from scratch, and I will copy and paste the code from my previous video. Let's do like this. Make dir data extract load. This is my first folder, and then I will do make dir data transformation, and also I will make dir orchestration. These are the folders that I have. I will have one part that is DLT, the data extract load. And then we have data transformations, which is the DBT part. And then I have orchestration, which is the Dagster part. As simple as that. Okay, let's start with our data extract load. And I will copy this script here. I copied the script into here, and you can see this is the load job ads.py. This is the DLT script that we have worked with before. And yeah, there's some more comments than what I have showed before maybe. But basically it's the same. We have here DLT. We have this get ads for the job tech data. And then we have this job ads resource where we yield the ads, right? We yield the ads. And then we have this definition for run pipeline. And then we have this if done the name equals done the main, that we can run this script directly in this Python script. Okay, this is the original. Okay, let's change this that we can use it in Dagster. And to change this, basically it's like this. We'll remove these, pathlib and path, I don't need that. We will go down here, we'll remove if done the name equals done the main. I won't need that because I won't run this directly. Dagster will run this for me. I'll remove that one. We will remove the run pipeline is not needed anymore because the run pipeline will be used inside of this pipeline, will be defined inside of Dagster. I'll remove this entirely. Or actually, I can use it later, actually. I won't remove it directly. I will just comment it out, and then I will remove it when I have created the Dagster part. Okay, this becomes much simpler now. What do we have here? We have our getAdds. What we need is the parameters, because I want to do the same here. I copied this part, or I'll just move it up and move it up. These params, I want the same parameters as before. And then we will need to have something called dlt.config load.truncate staging dataset equals true. Okay, what is this, you may ask? By default, DLT and Dagster will create a staging dataset. It will have another underscore staging where it places the data. And what this does is that it will clean this up. This is why you need to add this line here. It will clean up the staging. It means it deletes all the rows in the staging underscore staging schema that is produced by Dagster. It just cleans it up. That is what you need to know about this one. And then let's move on here. Let's look at the resource here. We worked with resource before, but we will need to work with source. That is what Dagster will need. First, let's change this a little bit. We'll take another parameter, table name. We'll call this job ads. This is the table name that we're creating. It's the one that will be outputted inside of our staging when we are loading the data, right? And this is the same. And then we will go into make it into a source. Then you have at dlt.source and then def job add, let's see, job ads underscore source, and then return job ads resource basically. And we put in our params. The params that we have here, we place it into this job ads resource. Just as simple as that. And note, we need to have source because Dagster requires it. Dagster works with DLT source, not DLT resource. Basically, a source you can place in several resources if you want and collect them into a DLT source. And DLT resource is the smallest unit, but you collect several resources into a source. But right now we only have one resource in this source, and that will work well. Okay, now it's time for data transformation. I will paste in the code from the DBT modeling. Now I'll copy the code from DBT modeling, go into the data transformation, paste it in, and here it is. And basically, I don't need many things. Let us delete DBT packages. Let us delete logs. That will start from the beginning. I will explain a bit. The target is when you do DBT build or DBT run, then this target folder will be created. And what you will see is this manifest.json. This is the file with all the metadata about your project, about your DBT models. You can see this is the metadata, DBT schema version, etc. It is quite long. I'll do auto formatting here and you will see how it looks like. You can see 11,000 lines. And if I scroll up a little bit here, you can see, okay, which DBT version I used, which project name it was called, DBT code. and a lot of different things. You can see here database job ads and schema staging, etc. And you can see here's the source job ads. Everything about my project is here except for secrets. I will do Command Z to go back here. This is the original file. Close this down. And I will keep this target folder here. And then we will have DBT project, YAML, a package lock YAML, and packages.yaml. So these are for the packages. And we have macros models. And I forgot to say about the target and manifest.json. This file is super important. It's important in the way that Dagster will point towards this file, that it knows about our DBT project. It knows about all our models. That's why the manifest.json is so important for Dagster. And now I'll move on to the models, and you can see we have these models. We start here with sources, and then we have SRC job ads and SRC occupation. We'll need to go into sources and change a little bit here. Yes, what we need to add is some metadata. We have meta here, a tag. This metadata specifies the corresponding Dagster asset for this DBT source. This is what Dagster requires. Dagster asset key. I will call this DLT job ads source. This is what the Dagster will require. This is the small change that we need to make in our source. Otherwise, we have our SRC job ads, and we have our SRC occupation as normal as well. And then you might remember the lineage. These are taken from the source job ads, and the occupations from the staging. And then we go into our warehouse layer where we have fact table and our dimension tables. Now we have only one dimension, but we could have several dimensions. We have one fact. And then finally we go into our marts layer where we'll have our technical job ads. Our mart technical jobs, where this is the things that we want to serve for the end user. Okay, we take a look into our DBT project.yaml. And here you can see the name is DBT code of this project. And the profile is dbt_snowflake. I have connected it to my profiles.yaml. And then there I have one configuration that is for Snowflake, which I've called it DBT Snowflake, which I use now. For different projects, you could have different profiles. But this is found in our profiles.yaml inside .dbt in our home folder. If you look into the terminal here, I can show you where it is. You can have like ls. Here, this is going to a home folder and .dbt. In this directory, DBT directory, we have this profiles.yaml, and inside this one, we have our profile DBT Snowflake, which we have all our setup. And now, since I deleted the packages before, we need to get back our packages in order to use those packages. To do that, I will go into CD, data transformation, and here I will do DBT deps. And this basically just install all the packages. Because I deleted it before, I could have chosen not to delete it, but just to show you what to do if you don't have it. We need to have this DBT packages. I've only installed DBT utils here, but if you have other things, it will be installed here as well. And that is defined in your packages.yaml here exactly. Okay, great. And now you should know that we have connected with DBT. However, you can see that we don't have any connection here to Snowflake, but that is also needed. I'll close this down. I'll go into orchestration. Here I will go CD back and go into orchestration. And inside of orchestration, I will make dir .dlt, and then I will do touch .dlt/secrets.toml. And here in the secrets.toml, you need to put in your configurations to connect to Snowflake. I've shown that in a previous video. I won't show it here. For me, I'll just paste and move on. I pasted this secrets.toml. I won't show it to you. Instead, I will create the important file of definitions.py. And as I said in the beginning of the video, if you're working with Dagster, you usually want to do Dagster init to create the whole scaffold. But for simplicity, I'll place everything in definitions.py. But for that to work, we need to do a few tricks. Okay, starting with from pathlib import path, because I will need this to point towards different places to find the different important files and directories. We need to have DLT. We will import Dagster as DG. We will have from Dagster DLT import Dagster DLT resource DLT Assets. From Dagster DBT import DBT CLI resource, DBT project, DBT assets. Okay, I will go through each of these soon when we use it. Just write it down and I'll show you soon. Okay, here is another important thing that we need to do because we are not working in a package. I don't have any packaging, cannot import from folders, and because of that, I will need to do this. Import. This is ugly way to do it, yes, I know, but it will suffice for this demonstration. .path.insert /data extracts load. This gives me this path that I can have this inside of my path, and for that I can do this from load job ads, import job ads source. If I run this one, it shouldn't give any errors. Yeah, exactly, because now it's possible for me to access. It gives me an error. Let me think why. Okay, the reason why it's simple, I accidentally placed it inside my .dlt folder. I'll just move this definitions file out into the orchestration. Now it looks correct. .dlt and definitions is in the same level, and I needed to put in .dlt here because of this file will look into the .dlt later on. Okay, I'll just run this one. And we'll see that there is no error right now. That means it works. I can import this job ads source. Let's move on. Starting with the DLT asset, we'll do this. DLT resource equals to Dagster DLT resource. This creates an instance of this resource class that we can run the DLT code. This is very important. And then we need to create our DLT assets. And to do that, we'll do this DLT assets as a decorator. And basically what it is here is we need to have a source. DLT source is basically what source is it? It's this one that we have imported, right? If you go into load job ads, you can see here job ads source, right? This one we have imported. This is the ones that we'll pick it from. Job add source. This is our source. And then this DLT asset, what do we want it to do? We want to have a DLT pipeline. Remember that when we're working with DLT standalone, then we'll define a pipeline and we run it, right? And the same idea is here, but it's just wrapped in this decorator. We'll have DLT.pipeline. And we put in our pipeline here. Let me go back here and just copy this part. It's basically this one here. I'll copy this one. I'll paste it in here. And this is called DLT_pipeline. And this I will remove here. And I can actually remove this part here. I don't need that anymore from my DLT. Okay, this is it. We have our DLT source here from this job ad source. That is, we really remember we had the resource there where we go into the API and pick the data and yield that. And then we have this DLT pipeline. The pipeline name is job search. And then the destination is Snowflake and the data set name is staging. That is our schema, basically. Okay. What are we decorating? We need to decorate something special. Def DLT Load. You can call this whatever you want, but I call it DLT Load. And now comes some Dagster magic or some complexity that I need to try to explain. Context dg.asset execution context DLT colon Dagster DLT resource, the one that we imported before. Okay, why do we need this? And then we do something called yield from DLT.run context equals to context. Okay, there is a lot of things happening in these two lines here. What this means is this is a type of dependency injection that Dagster, what it can do is that the Dagster framework, it will construct instances of necessary classes needed to produce the assets. One is for the metadata. This context is for the metadata, and the DLT is for the running the DLT codes. These are needed for Dagster. This is called dependency injection. We're injecting these two objects into Dagster that it can create instances based on it. Okay, that sounded a little bit difficult, but you don't need to understand exactly how that works under the hood, because you just need to know how to use it. This is the requirement from Dagster, okay? And then we have something called yield from, and what this means is that it passes the values from DLT.run directly to Dagster, one at a time. It means that the asset is streaming data from the DLT pipeline to Dagster. You have yield from, it means that the asset here is streaming the data from the pipeline of DLT into Dagster. Whenever we have data, we will stream it to Dagster. That is basically what happens here. Okay, that is our DLT asset. And then we'll move on to our DBT asset. I'll have a comment here, DBT asset. And for this DBT asset, yes, we will have it like this, but I'll just comment it out. We haven't come here yet. We need to define a few things first. First, we need to have DBT project directory. And this is the path. Then the file dot parents of 1. Here you have done the path is this one, parents of 1. We go up one step and then we go into the data transformation. We go into this folder here because here is all our DBT code. Okay. And when we have this, we will need to say where is our profiles. Profiles dot directory equals to path.home path.home/.dbt. The path.home, it will go into your home directory of your computer, and then we concatenate it with this code, this DBT. Because if I print out profiles directory, you can see what happens. You can see here /users/engineer/.dbt. This is the directory where my profiles is. Because like I could do this, I could do ls/users/engineer.dbt, and you can see the profiles here. This is the directory where my profiles is. Okay, remove that one. Now we will go into, we'll create an instance of a DBT project. DBT project equals to DBT project, this class that we have imported. And the project directory is our DBT project directory. It requires this one. And the profiles directory is the profiles div. Okay, these are just to instantiate our DBT project instance. Okay, what can we do with this DBT project? You will see. We will need now an instance of our DBT CLI resource. DBT resource equals to DBT CLI resource. What is this? We need, let me just write this first. Project directory is the DBT project. This is an instance from the DBT resource class to run DBT code. With this CLI resource, you can basically do DBT run, you can do DBT build, you can do DBT test, etc. All the DBT command line, they exist inside of this class. With this one, we can run those in our Python. When we're running Python, during runtime, we can run these commands. And why do we need that? Because Dagster requires it. Because Dagster need to be able to run DBT build, for example. It needs to be running DBT test, etc. It needs this. And now we do like this. DBT project.prepare ifdev. It prepares a DBT project at runtime during development, i.e. when Dagster dev is used. This method, blah, 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 okay? What it does is that it will ensure that the DBT manifest file and DBT dependencies are available and up to date. Basically what it does is that during runtime, it will create the manifest.json that I showed you before, where we have everything, all the metadata about our DBT model is there. That's why we do this one, to get our manifest. Basically here is to get the manifest in runtime. Okay, these were a few things. This one is needed for the CLI commands, such as DBT build, for example. e.g. Okay. And the other ones are self-explanatory. Here's just an instance of the project which we need. Okay, now it's time for us to create our DBT assets. Okay, then we do this decorated DBT assets. And here it requires that we put in a manifest. Where is our manifest? It's in our DBT project.manifest path. This one will just point to where our manifest is. Okay. And then def DBT model context dg.dagster.asset execution context for the metadata. Remember, we're doing dependency injection now, as before. DBT is our DBT CLI resource that the Dagster can create the instances of this context and this DBT that it can use it for different things. And then we'll have yield from dbt.cli. Now we use the DBT here is the CLI resource, which means that we can put in a CLI. And what do we need? We do build, we do DBT build, and then we do context equals to context. They can get the metadata, and we do .stream. And stream is for that we can get our data, the progress in real time in Dagster UI. That basically everything that the models is doing is when we're doing build, we'll get the result and the progress in the UI that we can take a look into it later on. That's why we're doing streaming. Okay. Now it's time for the different jobs. We have the assets, but the assets, they won't do anything. We need to put them into jobs that we can execute. Okay, let's put them into jobs. Job DLT equals to, let me just scroll up a little bit. And here we have job DLT. Usually when you have a full Dagster project, you have these different things in different modules, different files. And now for this simplicity, we put everything in definitions. Selection equals to Dagster.asset selection.keys. And here, remember what we had in our source. In our source, we put a name, the asset selection keys. If you remember, we go into data transformations. We have our, our macros, models, targets, our models, right? Source, sources.yaml. We have this one, and it should be the same. I copy this one, paste it in here, source, and then we'll have a job. That is our DLT, and then we'll have our DBT asset jobs, Dagster.asset selection key. Instead of keys here, we'll have key prefixes. The key prefixes here will go into our warehouse, our marts. These are the key prefixes for our DBT, right? We have our DLT first, we load the data in, and then in our job DBT, we have this warehouse layer and we have this marts layer where these are the ones that will materialize, right? These models will materialize. That's why we have this warehouse and marts here as key prefixes. Okay, and then let's do a scheduling here. Schedule DLT equals to Dagster.schedule definition. And here you can schedule whenever you want. Job equals to job DLT. When do I want to schedule this? I want to get data loaded in with a certain cron schedule. For example, I want it to be 15:13 every day. For example, this could be every day at this time it will run. And then we'll have a sensor for our second job. The first job is the DLT. We schedule when we get the data in. And whenever we have the data inside, we want the other jobs to be triggered, right? Then we need to have something called a sensor. We have dg.asset sensor. And here we have asset key equals to Dagster.asset key. And here is the same as this one. This is what I want to look for. It should, every 30 seconds, the sensor will take a look into this asset here, if it has materialized or not. And then this job name, I want it to be called job DBT. Or I want this job DBT to go on when this has been materialized. Okay. We have def DLT load sensor, and what we want to do is yield this dg.run request. Basically, it's just that it will make sure that it will run whenever, when the other one is, when it has been loaded. It's a trigger. Okay. And then finally, we have our definitions. And this is a Dagster object that contains the DBT asset and the resources. Defs equals to dg.definitions. And for here, we have assets equals to DLT load and DBT models. And then we have our resources equals to DLT resource. It requires, for DLT and DBT, you need to choose which type of resources there are, and you need to choose which type of assets there are here. Basically, this DLT says that it's a DLT resource, and then we'll have, this is the dictionary, DBT is the DBT resource. And then when we have our resources, we need to have our jobs equals to job DLT command job DBT. And we have schedules equals to schedule DLT. And you have sensors are the sensors that we want to have. Basically, this is the definitions. This is what, when we do Dagster dev, this is what Dagster will look for to run our different jobs, which assets we'll be using for the jobs, which resources, etc. Okay, now it's time to run this one. So make sure that you have activated your virtual environment. You're inside of this orchestration folder, and you can reach definitions.py. So then we do Dagster dev -f because this is a file and we're not running the whole package. We don't have any packaging here. So Dagster dev -f definitions.py. And now I'll run this one. Dagster web server needs to be installed. Yeah, that's true. uv pip install Dagster-web server. Okay, now let's run it again. Okay, there is an error. Let me debug. Okay, my bad. I forgot to install another thing. So what you need to do is uv pip install dbt-snowflake because it said that the Snowflake adapter was missing. So after you install that, it should be fine. So then when you have installed that, let's run Dagster dev -f definitions.py. Okay, so it will launch the Dagster services. Okay, so now you have a web server on port 3000. Let's go into that one. So you command click it or control click it. So here you're in the Dagster web server. And here you can see the different runs. We don't have any runs yet. We have assets. Here are 4 assets that we have. You can go into the jobs, and here are the jobs. Automation, here are the different things. And we have DLT sensor and job DLT schedule. So what you can do is that you run this one, or you need to activate them the first time. Let's click on this one, actions, what do we have? Yeah, we have started those. Let's go into jobs, and we can see that we have this DLT sensor. Let's go into deployment. You see this is the definitions.py that we have deployed. Okay, and now we should go into our assets. Let's see, you can go into the lineage, so view the lineage. And this is quite cool. So you can see here DLT job adds source job. So source job adds resource. So this is DLT. You can see that DLT Snowflake. And then you can see that this data here goes into dim occupation and fact job adds these are the DBT in Snowflake. And then it will go into our marts. So you can see the lineage quite nicely. So for example, if you go into here in dim occupation, you can directly see the raw SQL code. This is a really nice way so that you can follow along how the data has been transformed during its lifetime. You can see it's going from this one and then going forward. And then we have our schedule, right? That one has already been defined and activated, so we could wait for it, but that is way too long time because I defined like 1513. So let's do materialize all to manually materialize this. So I'll materialize this. So what you can see, it's running this one, and then it will move forward to run the rest here. You can also see the runs here. So it says started, and it takes some time to get the data basically. And here you can see they are materializing here. Let's go back to the lineage. So it says run, currently refreshing this asset. We can take a look into the logs, what is happening here. So you can see that it's launching this subprocess DLT load, and then you can see what it has yielded, and then it says the step has successed. Okay, and you can see the full message if you want. So here are a lot of metadata about how the run went. You can see that, okay, a destination is Snowflake. The dataset name is staging. That is where we want it to go. And then you can see the jobs. You can show JSON, and you can see some metadata about it. Okay, close this one, close this one. Done. So this is done. And then here you can see they are done as well. So the other ones are done. They are based on this one. So this one needs to be done before these are working, right? So before the DBT runs. And that is because of our sensor that is checking each time, checking that this one is finished or not. And also one important thing is that you can think, okay, the DLT, it will take longer time, of course, because we're loading the data from the API. And then, okay, then a question might be like, how can Dagster know that we have all our models here? Remember that we put in our manifest.json, because we put in a manifest.json with all our models and all the metadata there. So it knows. So then it can, and we also chose the warehouse and the marts layer. We defined that in the code before. So you can take a look into this one. You can take into the latest materialization. And when this is done now, like 1 minute ago or 2 minutes ago, you can go into Snowflake to check that the data actually is there. Okay. So I have opened up the Snowflake and note that it's taken a few minutes. So now you see it's 6 minutes ago or 7 minutes ago. This means that the time is around 15:54. So then looking into the data here, the database explorer, here you can see DLT loads. You can see all the metadata when the loads happen, and you can see the latest one here, job add. Yes, it's called job add source because that is what we define it as. And you can see 0927, which is today. And here you can see, and this is UTC time. So you add on the hours to become in Swedish time, and it corresponds to the one that we have put in. So here you can see this is the job ads, the one that we have. So you can see updated job ads here. This is the data that has come into the staging and the data preview here. So this is the latest data that has come in. Okay. So these job ads, you have the staging, right? Then you have the warehouse and then as well. For example, you can take a look into the marts, the tables and mart technical jobs. So this is after DBT has run. You can see the data preview here. And this is basically what we have in our, and yes, here is the data that we have loaded into Snowflake. And then afterwards we have done transformations on it. So you can see the data here. Cool. So I have created this Dagster tutorial now where we use Dagster to orchestrate loading the data in with DLT and then working with the DBT models to transform the data, and the data is saved inside of Snowflake. So that is really cool that we managed to use Dagster to orchestrate this, and you can see the schedule is on, so that it means that each day it will run these jobs. And of course, if I close down the server, then it won't run it. But the idea is that you could have it on a server, either on your own computer and have it on all the time, or you could deploy it to somewhere, for example, a virtual machine in Azure, for example, and then you could have it up and running. And you can have the data coming into Snowflake and updating and the jobs running. And then when you show, for example, downstream, you can use a dashboard to show the data and take data-driven decisions. Then you have updated data, latest updated data. So that is, you can see the pipeline is running automatically, and that is super cool. So that make sure that you base your decisions or the company's decision on the latest data. So super cool. And I hope that you learned a lot from this video. I know it's a handful, it's very long. And the thing is, this is the first Dagster video I made. So I will, as I said before, I will probably make more Dagster videos and go from the basics and up to more advanced topics. So yes, thank you for watching this video and see you in the next one. Bye.